Hello and welcome to Data Science in Industry vlog. My name is Konrad Wojdan and today I would like to tell you about typical schedule, typical steps of a data science project, especially the project where we apply the AI method in selected type of industry. It could be power, gas, heat, manufacturing sector, it could be intelligent building, but generally this is related to the projects made for industry. I'm doing such projects for the last 18 years, working in transition technologies and now transition technology science. I would like to share the knowledge and the experience that me and my team, gained over the last 18 years. This is some kind of a synthesis of typical steps. So I hope that after this video you will get a feeling of a typical, let's say, project in this field. I mentioned about my team. I would like to say high five to all my teammates. In the last video I was talking about how it's like to be a data scientist. And I forgot to mention that the most important thing is that you are a team player. Especially the big projects must be made by teams of data scientists. And this is really important to be a good team player, to get along with your teammates so you can easily share knowledge. You can do the brainstorm meetings. This is important. And I think this is also a big advantage of this path of career, being a data scientist, that you have this possibility to work in a team. So once again, thanks for all my teammates. And now let's focus on those typical steps. Here you can see those typical steps. First of all, at the very beginning of the project, you have to activate your detective mode. So you need to understand what is the goal of the project, what is the nature of the industrial process that you will deal with, where is the value to the user. Then you need to understand where are important data, where they are stored, how they are stored, what is the quality of this data, the data that can help you solve the identified problem. Usually the next phase is dealing with the bad quality of the data. So we need to understand what is wrong with the data that we acquired. Maybe the data are okay, but my knowledge about the process, about the domain, is not enough to properly interpret the data. However, in every project you will get corrupted data, missed values, bad quality data. This is normal and typical, and this is very important to identify those data and do something with it. Get rid of this, or maybe improve the data, fill the missing values. We'll talk about this later. Then we need to clean the data, do the data wrangling. So this data wrangling process, I will tell you about this more later on, will help us to have a better form of a data. Maybe we can create some new features that will help our machine learning algorithms to find the patterns that are within the process and better predict the outcomes of the process, better detect anomalies, predict failures, and optimize the process. Then we need to, and this is, let's say, this is 90% of the project, typical of the project time. Then when you have a proper data on the table with a good form, you can start playing with the algorithm. You can test many approaches, develop your own algorithms. And of course, the form of the algorithm depends on the task. It could be a machine learning approach, time series analysis, statistical approach. Depends what you need to do. And the final phase is to show your work to the world. So depending on the nature of the project, it could be a report or a scientific paper, if it's a scientific project or a consultation project. Maybe you need to integrate your AI algorithm with the IT platform that operates within the plant or factory. Then you have to think about the communication with this platform, about the API, about the cybersecurity, about the changes in the control system that allow us to push our decisions to the devices. Maybe it's a part of a web platform, or maybe this is a POC project and the customer would like to see some simple graphical user interface. Then there are plenty of tools where you can extend your machine learning project with a nice graphical user interface. Maybe not very complicated, maybe not very sophisticated, but a simple graphical user interface so the customer can play with your algorithm without launching the Jupyter notebooks or the Python console. So now I would like to discuss all those steps in details, but please understand that this is the typical workflow. And of course, we can get back to previous steps from time to time. This is normal, so it's not, just linear process. From time to time, you have to jump back to the previous step. This is very important to understand that let's say, errors, let's call it like this, error or bugs made in the previous steps will affect the end results. So the sooner we identify, let's say, problem with the data, or the sooner we really understand the goal of the project, all the constraints, decision variables, where is the value to the user, the better. Because if we will, let's say, skip some issues related with the data quality in the first steps, then we will see that the accuracy of our model, maybe some process situation in some process states, is not enough, and we will have to get back to previous steps. And this is always related with some cost, with some time. So definitely it's better to do it as soon as possible. However, it's not always possible. I will discuss this later. So, the detective mode. Usually on this slide I'm doing the workshop with my students. So now you can pretend that you are the data scientist and I'm the, let's say, customer or a business partner. So let's pretend that I'm the owner of the underground gas storage. And I tell to you that I would like to have an IT system that forecasts demand for gas nominations in a gas storage. Now it's your turn. It's the time for turning on the detective mode and start asking questions, start generating hypotheses. First of all, I think you need to understand what is the underground gas storage, if you don't know it yet, how it's operates, what are the gas nominations, right? So of course you can read the books about this, read scientific papers, watch YouTube videos, ask your colleagues. Why not? This is a project for a team, right? So maybe one of your colleagues have worked in such an underground gas storage or have something to do with this kind of projects. So let me explain. The gas nominations are the amount of gas that you would like to inject or withdraw from the underground gas storage. They are defined for each hour. So let's say I can say that for 11 a.m. for tomorrow, I would like to inject X normal cubic meters to the gas storage. All right. So, what is the gas storage? There are, let's say, different kind of gas storages, but here in Europe, the most popular ones are the cavern-based gas storage or the porous structure gas storage. So the cavern gas storage is, let's say, a plant where you store the gas in big holes underground. And in order to inject the gas or to withdraw the gas, you need to use compressors and, of course, other facilities. In case of porous structures, you store the gas within the pores. So it's not the hole. There is some rock formation that have small holes in which the gas can be stored. So, of course, if I mess something and you're an expert in the gas storages, you can write the comment. But this is a very, very brief introduction, right? Okay, so what questions would you like to ask right now? You can think of it. Some obvious questions are, what is the time horizon of such a forecast? So I can tell you 2 days. 2 days because I need to use this forecast to operate my gas storage in the optimal way, and because of the startup times and startup costs of compressors, process dynamics, and the need to scheduling the work, I need to have this two days horizon. So if we know the horizon, we can ask for the time resolution, right? Time resolution of this forecast. Well, as the owner of the gas storage, I can tell you that 1 hour it's the good time resolution. You can think about next question. So now you have a general feeling of what's the goal, but of course you can ask for profiles of customers who inject and withdraw gas to my gas storage, right? What kind of users do you have, customers? Who, from the business perspective, who and when injects the gas and who and when withdraw the gas. So you feel the context, right? Whether it's an industry, whether those are households, maybe this is some customers have some wind farms and would like to, and some gas turbines and would like to, and an energetic cluster, yes, and would like to play with your underground, with my underground gas storage. Maybe it's a third party customer who plays on the market. It's important to ask those questions to understand the business context. Why do I need this forecast? Right? How often I will need the update of this forecast? So I can tell you every renomination, or maybe not. Let's simplify it. Every day at 6 a.m. I need the new forecast. Let's pretend, right, that this is the frequency of execution of this forecast. You can ask if I would like to start this forecast manually, or I would like to have it automatic. I can say that at 6 a.m. I'm drinking coffee, so let it be automatic, right? You can ask, what if the crucial conditions that affects this forecast changes? Do I need the update of the forecast? I would say, good point. Yes, it would be great if you can update the forecast if crucial conditions will change. So another question is, what are those conditions that affects? What are those parameters that affects the forecast? So this is a question for you as a data scientist to think. But of course, you can ask me, and you have to be you have to be, let's say, a partner to your customer. You should not afraid to have brainstorm discussions with the customer. There are no stupid questions, such an approach always pays off, I think. So you can ask me what are the conditions that affects parameters that affects the forecast. I can tell you that for sure the temperature. If let's say if my customers are using the gas for heating households, the temperature would be an obvious choice. But maybe other weather parameters. Now, if you know that the households, the people, the end users that consume the gas are part of the game, then the hourly profile of activeness of those people is also important. So for sure, things like hour of a day, type of a day, is it a weekend or a normal operating day, or working day? Is it a holiday, right? So such things will affect the gas consumption and will affect probably the nominations. Maybe there are some macroeconomic or microeconomic parameters that affects the forecast, like gas prices, oil prices, the indexes, the parameters related with the industry. This is something that we can write down, that those are parameters that could affect the forecast, but of course we will have to evaluate but in later steps evaluate if those parameters really affects the forecast. So you can also ask if this is a gas demand forecast. So this is a real gas demand of end users. So what they really want to inject or withdraw from the underground gas storage, or this is a demand limited to the capacities of the underground gas storage, to flows that are possible with the utilization of above ground facilities like compressors. Because, well, maybe I would like to inject X normal cubic meters to your gas storage, but to my gas storage, but because of the gas compressor limitations, so because of the limitation for the flow, for the current pressure pressures parameters, you can only inject half of X to my gas storage. So let's say that I will answer you that I'm interested in the demand that is limited to the possibilities of the gas storage, which is a great answer for you, because then you can rely on the history that is, I hope, that is stored somewhere in the IT system, the history of nominations. Yeah, so you can also ask about this history, about the data. This is also, we will have another step about the data, but this is always also a good time to ask about data sources. Do you have a history of nominations and parameters that affects the nominations? So let's say the weather, the history of active user, who was nominating and when, what was the limits, the history of limits or the constraints of the underground gas storage. So 6 months ago, maybe there was some service action performed within the gas storage, and the flow limit was reduced. Yeah, so this is the good time to ask the questions, and of course the typical question of the customer is how long should be the history that I will export you, right? Because of course we would like to have the obvious answer is the longer the better. The more data you will send us, the better. The customer can also ask about the resolution of data. We can say 1 hour resolution is enough because our goal is to create the forecast with 1 hour resolution. But maybe you would like to have a higher resolution in order to check the quality of the data, to catch some errors in the data, depending on the project. It depends on the project. And of course, let's say if we get the long history, let's say 10 years, I have a 10 years of history of nominations to my gas storage. The important question is, from your side, from data scientist side, is were there any crucial changes to the underground gas storage operation over those 10 years? Maybe I added some new caverns to my underground gas storage. Maybe I changed the compressor to the bigger one, so the higher flows were possible. Maybe 4 years ago, the new customer came in, the crucial one. We changed everything in the gas storage operation, and I had to change my strategy for using the underground gas storage. So this is important thing to ask. Of course, you will see it in the data that there was some changes, but knowing this in advance can really help. So such a workshop could take 2 hours, a day, 3 days, depending on the project size. But this is a very important step. The first workshop, where you will openly talk with the customer to understand the business context, the physics behind the process, the limitations, data sources, and of course the customer will well, this is also important from the, let's say, social point of view, because you will learn about each other's. The customer will learn about you. You will learn about the customer. Maybe this relationship that is established during this first workshop is very important because this partnership relation should be based on trust. This is the keys to success. Okay, so now let's switch the project for a while, and or maybe let's stay with this task. But during the workshop, I must, as the owner of the underground gas storage, I also asked you to help to optimize my maintenance strategy, because the maintenance costs are high. I'm doing the service actions every half a year, and it costs me a lot, and I would like to optimize it a bit. Maybe I have some problems with the devices on the plant. So this is the topic also covered by the Industry 4.0 phrase called predictive maintenance. You as a data scientist, you can propose your customer predictive maintenance approach. In order to do so, you need to really understand if this is really the case for the customer. Will it help? So you should ask, what kind of problems do you have with your devices? Do you have devices that are broken very often? Do you have some problems with particular failures of particular part of the process, particular devices? Here it is very important to identify such devices and faults related to those devices that are crucial to the system, so that the cost of those failures is high. Because if it's low, then maybe it's the cost of implementation of predictive maintenance strategy is too high. But if those are the crucial devices, and we can predict those devices in advance, the application of predictive maintenance strategy will pay off. So what are the crucial faults that are associated with the high cost? Are they often? Because if it happens once, I don't know, 12 years ago, then let's skip it. Maybe the predictive maintenance strategy will not pay off. But if it's the real pain for the customer, then why not? It's worth to try. Another question is, if those faults, if we know about those faults in advance, so we can predict them. If we can predict them, can we do something with this? Because even if we predict the fault, but no action will be taken, we will just run our process and wait till the device breakdown, then the predictive maintenance strategy has no sense. But if we can do something with this, then we should apply such predictive maintenance strategy. For instance, if there is a pump that makes problems, that is associated with a high number of faults, and we can predict it in advance, we can suggest the user to switch to another pump, right? Here, in case of underground gas storage, compressors are crucial devices. If we can predict that there is one compressor that is characterized by high number of faults, especially in some selected process points, let's say in medium loads, then we can optimize the operation of underground gas storage in such a way to, of course, to minimize cost, but also minimize cost of the maintenance strategy. So we will try to avoid those process points that causes faults. Or we can just suggest the user to switch to another compressor or decrease the load of this compressor. It's important that we can make some action. All right, and of course, another question is, do we have a digital log of history of those failures? Usually not. Unfortunately, usually not. Usually those failures are written down in some notebooks, dispatchers' notebooks, in some pieces of papers, but if the number of those failures is not very big, we can digitalize it by our own. Another question is, do we have a history of values related with this particular device? Usually we have. This is the good news. Usually we have. We can try to export it from some control system and play with this. In the predictive maintenance projects, our goal is to create a trap, a trap that is dedicated for a particular type of a failure. We won't like to catch the early symptoms of this failure. But I will talk about the predictive maintenance projects in a separate video. So let us assume that this part of the workshop is also done. Now we have to ask the customer to export the data, or we can do it by ourselves if we have an access to the IT systems. So we have to think, what are the possible data sources? Maybe in case of underground gas storage, we have a control system that controls devices in a plant, that tracks flows, pressures, volumes of gas stored in caverns. And of course, we can try to export this. Maybe there is a business layer IT system that stores the history of nominations and users. So we can ask for this. Maybe there is a history of weather parameters. Then we also can ask to export the history of the weather, the real measurements and predictions. This is also important to get the history of weather predictions, not only the weather itself. Okay. And of course, we need to evaluate or ask, what is the accuracy of measurements? We can talk with the operator or with the dispatcher and ask him, do you really trust those measurements? What is suspicious for you? We can ask, or we can take the manuals and check what is the accuracy of sensors, because we are using data from those sensors. This will be important, the next step related with exploratory data analysis. So this step is about exploratory data analysis. Here we have to dive into the data and check the quality of the data. This is very, very, very important step. Don't try to be fast. Don't try to skip this step and move forward to the algorithms, to machine learning tasks, the step where you're checking the quality of the data is very, very important. We need to understand how to join data sources and aggregate the data. Let's say we have the weather data captured every 5 minutes. We have nominations stored with 1 hour resolution. We have to somehow join them together. Let's say aggregate the weather data. Maybe we should calculate the average values, the average hourly values, or take the maximum value, let's say, of the temperature for a particular hour. Depends on the project. And like I said, after this, we have to do the exploratory data analysis to understand the modeled phenomena, the modeled system, and the business related with the system. So it's very good, at least for me and my team, to do very simple things like store the time trends of selected parameters, and really spend a day watching those time trends, understanding what happens there. This is very important thing. We can check, and we should check, the distribution of selected parameters, distribution of pressures, flows, temperatures. This will also give us the understanding of the process. If we have some initial hypothesis, we should see the relations between parameters that we think that are important. So we can do the scatter plots. I don't have, yeah, I will show it later on. We can calculate the correlations between system inputs and outputs, including the parameters that are shifted in time in order to evaluate the process dynamics. If we think that because of the process dynamics, the previous values of parameters are important, that are shifted in time, we should also consider them in the analysis. So if we are predicting the gas consumption, we should take the current value of temperature, but maybe also the temperature that was 24 hours ago or 1 hour ago. Why not? Let's check it. We can do the Pearson correlation if we think that the relations are linear, on Spearmart correlation if we think that those relations might be non-linear but monotonic. Moreover, we can check what is the correlation between potential inputs to our model. Because if there are two inputs that are highly correlate, we should not use both of them in our model. It's better to use one of them. Or maybe calculate some additional input based on those two. We can do the autocorrelation plots to check if there are some cyclic trends. If we are in this, let's say, field of underground gas storages, if the current gas nomination depends on the previous gas nomination. In the current heat consumption depends on the previous heat consumption. Yeah? All right. And this is also a very important step to understand what's there in the data. And when we are done with this step, we should do another workshop because we have a bunch of questions to the customer. That's for sure. Some of the questions are related with the fact that we not fully understand the process and the business context of this process. Some of the questions are related with the fact that the quality of the data is low. So here I can show you some examples. Those are artificial examples, but this is, let's say, the synthesis of examples from different projects. We could have, for instance, because of course there are obvious questions like some values, some parameters has a zero value or are not changing. We have to talk about this with the customer. But there are also some strange cases that we have to discuss with the customer. Like, for example, here we have, let's say, two customers, but when we see on the gas storage nomination time trends, we see that they are very similar, and the correlation matrix and the correlation between, correlation between those two nominations is very high. They behave, we see they behave very similar in very similar way, and we have to discuss with the customers, with the gas storage owner. Is it suspicious? Why do we have two customers that behave in very similar way? One is, let's say, Galaxy International, another one is GA Gas, and it could be that this is the same customer, but let's say they changed the name of this customer in the database. Once in the past it was called Galaxy International, now it's GA Gas, but still they are storing the nominations for him. One value is expressed in normal cubic meters per hour, the other value is expressed in gigajoules. Moreover, there is some shift in time, but it is related because one customer has one time zone, let's say the normal time zone, and another one has a summer time zone, and this is the reason of this time shift. But in fact, we should choose just one of them because this is the same customer. Maybe this is, an artificial example, but I want to tell you that apart from some obvious things, usually there are some things that need deeper analysis, the discussion with the customer, because for instance, like in this case, they are associated with some errors in the IT system of a customer. Or we can see that there were some nominations and it was zero for let's say the whole February, let's go like this, and then it was changing normally. So we have to talk with the customer. Really, in February the customer was not nominating? It could be that it was, let's say, the service action taken in the underground gas storage, and the whole underground gas storage was stopped for the whole February. We have to discuss it. This is more obvious situation. Here you can see those correlation plots. This is, I think, more for district heating networks. So if we try to predict the load, the heat consumption, maybe one of the inputs should be the temperature. And we can see that there is a correlation between the temperature, those are values related with the temperature, and the load. The lower and the load, so that the heat demand. The lower the temperature, the higher heat demand. So it's normal. This is how it should be. I would like to tell you about the next steps, about the data cleaning and wrangling step, about the creation of machine learning algorithms in the next video. If you have any questions, please write them in comments. I hope you enjoyed this video. If you enjoyed, please click like or even better, share it with your friends. Have a great day and see you in the next video.